Well, hello there and welcome to Skyter Livestream for the 31st of August. It's over, guys. Summer is over. Oh, no. That's okay. We're going to have a good time tonight. I want to just say hello to all of you, but before I do that, I want to let everybody know that our one and only Daryl Mason is with us. Hello, Daryl. How are you?
Oh, Mark, I'm good. Thank you. Yourself? Hello, everybody.
I'm doing good, thank you. So we are in the midst of a transition from summer to the fall, and
We are not.
well,
Summer ends on, what is it, 21st of September, 22nd? Everybody knows that.
actually, in winter lasts longer too. Winter lasts into April and May sometimes now,
Oh,
right?
you're talking meteorological summer versus astronomical summer. And
Yes,
me, as an astronomer, I look at summer ending on the autumnal equinox in the third week of November.
I look at summer as ending when I have to rush to catch Milky Way objects in the summertime sky.
Mm.
I want to say
Meteor-
hi to everybody.
meteor-
Sorry, go ahead.
I'm sorry, you go ahead.
I was going to say, I wanted to say hi to everybody, including PG Petita from Pennsylvania, who was here first. Justin T. Robin Curtis. Hello, Robin. How are things out in the greater Denver area? Actually, she's near you, Daryl.
I think I remember that.
Yeah, Izabela is with us. Hi, Izabela.
Hi,
And
Isabella.
uh, and we have Donald Kunzer is with us as well. And a few people, but you know what? We're gonna it'll build up here. The people that are here know the layout of the screen. I won't be going through that at all. I do have. Oh, NPC is with us. Hi, NPC. Good to see you again. Yep. And I did have a request before the stream started from Robin. She would like to know about the astronomical coordinate systems, and I figured that would be a wonderful thing to mention while we're here. First, I want to say hi to Alice Pooper and Anahata77. That's Bonnie, who's also about 5 hours from you, Daryl.
Yeah.
And M. Turner is with us. Good to see you. So, Judy McClellan, hi, and Jane Murdoch. I know Jane. James, how are you? Jane is someone who's a friend of the family, and she's been here before. She's been in the bunker. She knows what goes on here, but we won't hold that against her. David Schmidt is with us. It's good to see you as well, David. Wow, that's cool. We got a lot of cool people here, man. That's all that matters, right? That's all that matters. So, anyway, to answer your question, this is to Robin Curtis. Let's go back and look at our planetarium view. Okay, because our planetarium view kind of spells it out for us. And I'll back out a little bit to show us. I'm going to get rid of the star Antares, which is in the Scorpion, which you see right here. The Scorpion is about to lie down on its side and disappear entirely from the summer sky. But if you notice, when we look at, if we zoom out here, okay, and let's get rid of the constellations now so you can just see coordinates. All right, this is the coordinate system. Now that looks odd, doesn't it? Well, it's because the North Pole of the Earth up here, right, that is the top of the coordinate system. It's based on where our North Pole is. Now, because the Earth is canted at an angle, all right, the axial tilt of the planet, the coordinate system is not directly overhead. If it was, then we might see this, okay? This is how it would look. But it's not. This is just an altazimuth view where the horizon is at 0 and the top portion is at the zenith or 90 degrees. But it's not. The coordinate system we're using is called the equatorial coordinates. And so when we look at this, each of these lines means something, all right? And let's get rid of our constellation labels and some names and things and just go just to the stars, okay? So when we look at this, this is the North Polar region, right? Now, the North Polar star, Polaris, is not directly at the North Pole, all right? And by the way, we're not wasting any time. We're still waiting for it to get dark out there, so this is a perfect time to answer this question. All right, so this means that wherever you are, at whatever latitude you're at, then that's going to determine where Polaris is in your view, okay? Now, if you're at the equator, Polaris is on your horizon, right, roughly. So it'd be at 90 degrees to you, or 0 in the altazimuth system, okay? But here, this is at my latitude in Arizona, which is 33 degrees above the celestial equator, which is this 0 line right here. That's 0. See how it says 0 here? 0 degrees latitude, all right, is the 0 degrees of the celestial equator, the Earth's equator. Imagine latitude lines, which are these horizontal lines, okay, these here, and the longitude lines, which would be the lines of longitude in our system. Those are extended out into space, and we give them different names. The longitude lines are measured in 0 to 24 hours around the pole, because in one day we go through 24 hours roughly of space, right? In terms of the rotation of the Earth. And then we have a declination, which we call declination, which is the latitude, which is the angle above the coordinate systems at 0 and below. Now, depending on our latitude, we can't see below a certain latitude, right? So right now, we can see minus 10, 20, we can see down to minus 35 degrees if we could stick the telescope out above, and we can actually look at the horizon and see stars at minus 35 degrees.
Actually,
in Arizona.
Your southern horizon, if you're at 30 degrees
Actually,
north...
40, it'd be, 40, it's going to be just over 40, about 45 at most, maybe just a little less.
Actually, if you're at 40 degrees north, your southern latitude is 50 degrees south.
Right, but we're not. We're 33.
Yes, so your latitude would be 57 degrees south.
But we can't see down that low practically. That's correct.
Well, I mean, the southern horizon is that if you're at 33 degrees north, your southern horizon is 57 degrees south.
Yeah.
It's 33 plus 90 plus 57 equals 180.
Mm-hmm. Yep. So for us, that means that we don't get, we can't see down that low anyway, not only because the observatory is in the way, but because we have more air that we're looking through as we're looking along the curve of the Earth and seeing to those stars in vast distance. We're looking through more air, so the air will tend to disturb the images and make them not as good. We're here right now on Antares, which you see right here, because we would like to actually go to the comet tonight and start off with that. And to do that, it looks like we might as well give it a try. I have put in the coordinates here, and we're going to say go to and give it a shot. You'll watch the telescope move a little bit, maybe not that much, but it's going to do a high precision slew to try and find the bright star near where the comet is, and then it's going to take that bright star and use it as a waypoint to find other things. And we can actually bring back our constellation lines, our names of the constellations, and our objects. All right, so it's centering Dishuba, which is right there. So there's Dishuba. And from there, we should get to the comet, which looks like it. Is that it right there? I'm thinking that maybe it is. I think that's the comet.
Well, it's moved south quite a bit then.
Well, we'll find out, won't we?
Yep.
Because those are where the coordinates point us to.
Yep.
All right. Well, let's do this then. All right, one thing I'm going to do first. Yes, let me just do this. Okay. All right, let's move this over a little bit. First things first, I'm going to move the telescope a little bit toward the east. Center us up. How's it going, Bullwinkle? Hi, Fantasy. Hey, who gave us $5? I missed that.
Farva did.
Oh, hey, Farva. That's Sean. Thanks, Sean. All right, and let's go and try a 20-second exposure here. All right, of the comet. Let me go in first and set my guider. So we're going to go down here. And we're going to set the rate and make it 15. Do the declination, which is the equivalent of latitude. And we're going to set that to 17. We may change that throughout the course of the night. Hey, there goes a Starlink. And then there's another one, another satellite of a different kind from the upper right going to the lower left. This is live astronomy, guys. That's a lot of fun.
Yep.
Okay.
That's the Shuva. Comet has moved that far.
Yeah.
No, it was up by ACRAB the last time we looked. It seems to say it's moving faster across the sky now.
It may very well be relative to where it looks from the Earth's point of view.
Exactly.
Okay, let's go and... Okay, look, we're guiding right now. These are our guiding coordinates right there. You see right up above me there? All right. And let's now... Look, we got yet another one. That's a fast mover. Okay.
Thank you, Fantasy.
Hey, Fantasy, thank you so much. Thank you so much. That's very kind. Very kind. You guys are amazing. Well, let's give you something for your money, shall we? Let's do this 20-second exposure here of the comet and then live stack it and see what we get. Keep in mind, our live stack, we take one image, then we take more images and we stack them on top of each other, make an image sandwich. And that means that all this, the real meaningful data is really heightened, and noise, like the stuff in between the stars that isn't dust and isn't nebula, like just the blackness of space, that is actually more properly managed. So now we're going to process this. Oh, that's the comet. Look at that. Let's color correct
Sure
this.
enough.
Okay, now that I know we got it there, here's what I'm going to do. I'm going to go back and I'm going to start this again, but I'm going to do a 40-second exposure just to see what we get. All right? All right. So now we're doing 40 seconds, so I'm taking a little longer, give us a little bit more detail. Hey, Uberku. Prowl, what's happening? Nice to see you.
Yeah, I think the comet, from our perspective on Earth, is moving faster across the sky. It's going to be disappearing in the northern sky pretty quick. You remember it was up in southern Ophiuchus when we first started looking at it, and it took weeks to get down to ACRAB, and now it's only taken days to go from ACRAB to Dashuba.
Yeah, sure is.
Yeah, that plus Scorpio is setting so soon now that it's going to be going away here pretty quick.
Yeah. Well, let's zoom in. Oh, that looks pretty. There's the dust tail. Notice the dust tail is kind of a yellowish color. It's almost the color of our sunlight because that's what it is. Let's color correct, though, make it easier to see. There you go.
Yeah. The nucleus is still off center in the coma.
Yeah, it is. I think that's because that's the predominant direction it's heading. Now, here's what we're going to do. All right. I don't know if we're going to get to do this much, though, tonight because it's going to be setting. And the views are worse because it's down low to the horizon right now. But you see how it's close to these stars? In as little as 30 minutes, we'll see it move relative to those stars. And it's probably going to be moving pretty fast. Wow, this is cool. Alright, so what I'm going to do now is I'm going to try and actually make sure the color's corrected right there and do processing. And it's a little darker there. This is the coma. The green color is due to carbon molecules and due to carbon atoms mixed with nitrogen, a CN molecule, which is cyanogen, which also gives off a green color. And that is the result of the chemistry happening at the surface of the comet. Comets are made of many different kinds of ices, including ices from literally like primordial dust grains in the universe. And it's got a lot. There's hydrocarbons there too, which of course are the relative building blocks of life as well. Rubiku says, "Hey Mark, looks like another great night. That comet is stunning. Yeah, it's pretty. It's pretty." So we're going to try and get this. Now we're going to see if we can enhance this comet a little bit. Let's give it a little bit of sharpening. So let's check out and see how that works. Yeah, okay, that helps us see a little bit of detail. Oh, wow. Hey there, Papa Tom. Good to see you. Well, they were taking, for the questions about how they know what a comet's composed of, they were taking spectra of comets all the way back in the 1800s. And they were able to see the glow of certain elemental transitions in the atoms out there, and that led to the understanding that we see here. In fact, Flammarion, I think, was looking at the cyanogen in the comets, and he, of course, started a panic, which started cottage industries of comet pills to keep you from dying when Halley's Comet's tail swept across the Earth because of the cyanogen. Now, he didn't do that, but his comments sparked enterprising hoaxsters. Did Papa Tom mention something about Venus that I missed?
I'm sorry?
Did Papa Tom say something about Venus that I missed?
He was asking what the bright planet is in the eastern sky. If it's the really
Eastern?
bright one, is yeah, in the evening, I assume he means.
So is it Jupiter?
Yeah, probably Jupiter if it's a really bright one. Saturn rises first, Jupiter comes up.
Mars is up there too.
Mars is farther east, it's not up yet. Mars is in Taurus right now, I want to say. And Mars is moving east pretty fast too. Mars does that, before opposition.
Yeah.
Jupiter is a star right now, or is the star of the show, so to speak. Saturn has been up for some weeks now after dark, and it's kind of bright, and then Jupiter rises. Jupiter is well up by 10 o'clock now. It rises more due east, and Jupiter is quite bright. It's coming to opposition later this month. Saturn's in the east end of Capricornus, and Jupiter has moved all the way over to Pisces now. Remember a couple of years ago we saw them in conjunction in eastern Sagittarius or western Capricorn.
We saw them in one view.
Mm-hmm.
In this same view, we actually saw Jupiter and Saturn right above and below each other. It was pretty cool.
Yep.
Hey, Cosmic Ray, what's going on?
I still think the comet's pretty cool.
Yeah, it is.
And it may be my imagination, but I almost think I see a tiny little bit of gas tail at about 9 degrees, or at 9 o'clock from
This?
the nucleus.
That
Yeah,
thing?
just a bit, just a bit.
Yeah, that's why I wanted to go to 40 seconds to see if we could pull something out. I still haven't done any processing. I'll wait for a few more frames to come in. We've done 10 so far. Let's see. What was it? Fantasy. Fantasy says, I've been living in the desert for 7 years, so the heat doesn't bother me because there's barely humidity. But I laugh at the people who can't handle 100 degrees Fahrenheit / 40 Celsius, while I live in 110 and 45 Celsius. Well, that's true, but you got to keep in mind that you're leaving out the humidity factor as well. 100 degrees out here in Connecticut usually is accompanied by 70 or 60% humidity. When you have it, you have 6 to 12% humidity in some days. And at the observatory, I don't even need a dew heater, something to remove dew from the corrector plate, because the dew shield only goes so far that we have on there. You would need a dew heater to get rid of the dew. If I had that here, well, I did have this here, and I had a dew shield here too. And the dew shield worked to a point, but then you still got dew over the course of the night as the temperature dropped. But out in the desert, how long have we been going out in the desert? When did I put that observatory in? We're going, what, 2 years now, I think.
2 years?
Maybe.
That
at
long?
least. Oh, yeah, certainly 2 years.
You should have put a dedication stamp on it.
Yeah, I know. Well, it is the Maudlin Hain Observatory, named after the owner of the property, who's a good friend of mine, and named after Marianne as one of the benefactors. They were benefactors.
Mm-hmm.
The owner of the property let us put this on his property, and Marianne helped us with our finances and helped us secure funding for some of it. And then she and her late husband provided a lot of funding for us as well.
Cool.
Yeah. There's that dust tail. See it, guys? Right there. That green line, that is a guiding. It's a dead pixel, and as the camera guides, it just keeps dragging out that one dead pixel. Now they change a lot. They change over time. You'll see them change, and when I turn the camera on tomorrow, you might not see that. It might be somewhere else, if at all. So they vary, and I can get rid of them. But why bother? There's not that many. That is something else, though. Look at this. This is really pretty.
Mm-hmm.
Now let's try. Let me remove the. I'm going to take out the name for just a second here. Come here, you. Okay. And now we'll do some processing to see if we can actually. Let's see how much we've got there.
I'm going to rub it in weather-wise. We kind of get the best of both here.
Yeah.
It might hit 90s. Usually it's more like 80s.
Okay.
That's because of the altitude. And yet we're still a high desert, and it's often, humidity is, it might be in the 20s. Sometimes, though, it'll be down to single digits here. It can get just bone dry here. Have to run a humidifier.
Yep.
And down here on the Front Range, on the plains, there's an old saying that in Colorado, winter's in spring, summer's in fall, fall's in winter, and there's no spring at all. Our real winter usually shows up in springtime down here. Up in the mountains, a different story, though. They get tons of snow.
Yeah.
I've seen it snow every month of the year when I lived up in the high country.
Wow. I want to say hi to Cindy Murphy. I want to say hi to Taryn Marie. And, of course, DK. Nice to see you. DK 0018. And Sean Paris. Welcome, Sean. It's nice to see you here. If you haven't subscribed, please do. We do this kind of thing on most clear nights. We're looking right now at, obviously, the comet K2 Pan Stars. It's a gorgeous comet right now. And we know where we are in the sky because we could just bring up our beautiful system here to show us where we are. And we are, right now, let me just do this. Okay. All right. That is our ecliptic orbit. That is the ecliptic line. All right.
Plane?
Yeah. And let me.
The ecliptic plane is the path the sun appears to take across the sky from Earth's point of view over the course of a year. It's actually it's also Earth's orbit traced across the sky.
Right.
But all the planets except for Pluto follow the ecliptic plane really closely.
Mm-hmm. Okay, so
when we see that, Scorpius and Sagittarius are the two most southerly constellations in the zodiac. I think the southernmost point is actually between the two now. It's way down there, and that's why Scorpius sets so soon.
Yeah, let me check something here. That's interesting. Don't ask me how it happened.
What's that?
That's why I was messed up before. Our site wasn't right. Our site wasn't the right site here, but now that explains why we aren't 10 degrees above the horizon. We're actually 21 degrees above the horizon, which makes sense now. That's good. Coordinates don't change because that's a fixed coordinate system stuck out into space. Let's see what we got going on here. Wow, check it out. Now that's not bad, man. That looks pretty. Over here we have a bright star. Okay, and these halos are an artifact of the system. We get rid of those after. But we've done 22 stacked and a satellite. Zing! So that's
actually one of the nicer comets we've seen.
Yeah.
The last one we saw, Neowise?
Yeah, and before that it was Comet Holmes. Remember that?
Yeah.
And Holmes was just a green blob. Holmes didn't have any detail to it, but we did manage to track it. It looked more like, to us, it looked kind of like that. So now let's see how that looks when we zoom in, just so you can see. Okay, that's about as good as we'll get with the comet, But now, if we actually take this and bring out more data, now you can clearly see the dust tail here, the coma here. Very different green. Now we notice the comet, so let's pull that out of there for now. All right. Okay. This dust tail goes right up here. You can see it go quite high. Let's see if we can pull out a little more and use this other data intersection tool, basically a histogram, and see what else we've got. Well, you can see it goes all the way out of the view. If you look right here with your eye, then you could see the rest of the tail goes up here. Don't look right at this because you won't see it. Your eye precludes you from seeing it. You need more sensitivity. So look here and you see nothing. Look here, and out of the corner of your eye, you actually see it go up here. See that?
Yeah.
That's called averted vision. That's A-V-E-R-T-E-D, averted vision. And we use it in astronomy all the time when we're trying to look at faint objects.
Bright comets, they're just an occasional thing. Really bright showcase comets are a very occasional thing. They don't happen all that often. There are comets out there all the time, though. Dedicated comet watchers are out there every clear night combing the sky. They really do know the sky like the back of their hand, and they can tell a comet almost at once when they see a new one, see an object that wasn't there before. But those little dim fuzzies that the average person wouldn't even notice, or if they did notice it, they wouldn't think anything of it. Real showcase comets, oh golly, I don't know, you might get one every couple of years.
Yeah, I was going to say.
If that.
Yeah. Neowise was actually a showcase comet. We could see the dust tail and the ion tail, and then we tracked it for 45 minutes with the telescope here in East Coast, the Sky Tour telescope here, east, and we watched it go moving through the sky away from these tiny pair of two stars. It was really cool over 45 minutes.
Yep.
Yeah.
Oh, I've seen comets move. You can see them move in the eyepiece over just the course of a minute or two. Iris Iraqi Alcock, that was one that flew up by the North Pole, and you could, when it was at its closest, you could see the thing moving in the eyepiece. And Hyakutake, when it was closest, you could see it moving also. It moved halfway across the sky on the night it was closest to Earth. That was really something to see. It looked like a big blue spear flying across the sky. That was 1996.
Cool. Yeah.
And Hale Bopp. Hale Bopp never came that close, but
I saw
Hale
it
Bopp
in a light polluted area. I saw Hale Bopp.
Oh yeah. We could easily see both dust and ion tails on Hale Bopp here in town. It was a much better view out of town, though.
Yeah.
Hale Bopp was not close to us, but it was an intrinsically large comet, and
Right.
it was easy to see. Hyakutake was a smaller comet, but it came much closer to Earth. And that's one reason we saw it move so fast across the sky.
Right. Hi, Danny Johnson. Danny Johnson says, where is the ion tail? Well, in our view here, it's sort of not very obvious, but it might be mixed in with the dust tail because of perspective, you know. The ion tail always points away from the sun. All right, now this is heading toward the sun. It's going to go around the sun in December, actually end of December, I think. And then when it comes around, the ion tail is going to be pointing away from the comet, so it could be going into its own ion tail. But the dust tail always trails behind the motion of the comet. And this is the dust tail here. So it's possible that the ion tail is mixed into this, and it might be right about here. It looks like there's a sharp division right here that might be the ion tail, but the dust tail could be kind of masking it a little bit. We've been trying to do some processing here to try and draw that out a little bit. Another problem, I say it's a problem, but is we're actually getting some red emission nebula here because this comet is passing through a very populated region of the sky. So we're in Scorpius now, and this is a very Milky Way riddled area. So we are going to see nebula and nebulae as well. So they actually do muddy the waters a little bit, but I don't mind that. Makes for a pretty picture, doesn't it?
Yeah.
This line is a satellite trail, and the longer we take pictures, the more that trail goes away because it's only on one frame, and then the frame will, the next frame will have the black of space behind it, and that gets overlaid and overlaid and overlaid. So over time, these trails vanish. And Ubercrew asks, is that from the solar winds? The solar winds are responsible for a number of things. In the case of the comet's ion tail, the solar wind is actually charged protons and electrons zipping through space. Okay, they're responsible for the aurora borealis that we see on Earth because those solar winds spiral around. Those highly charged particles spiral in at our north and south pole to make the aurora borealis, the northern lights, and the aurora australis, the southern lights. Well, they also go and they hit the surface of the comet. When they hit the surface of the comet, then they react chemically, and they cause ions to be dislodged from surface materials on the comet. And these ions stream back behind the comet directly away from the sun because that's the direction that the solar flux or highly charged particles are moving. So it's always pointing away no matter where it goes in space. But then the dust tail is just this debris that is caused by the heating of the comet's surface. Outgassing occurs. Particles of dust are being shed all the time. Comets are like Pigpen in the Peanuts cartoon in Charlie Brown. Okay, comets leave dust as they walk along through space. They leave dust behind all the way. And then some of this dust, not in this comet's case, but in other comets' cases, the Earth will pass through that dust, that meteoric dust, which is the dust tail. And then we see a meteor shower. There are many meteor showers named for comets because, or named, caused by such named comets. So.
Yep. Two big ones are the Perseids in August. They just happened a few weeks ago, and they're caused by I'm sorry?
Was that Swift-Tuttle?
Swift-Tuttle, yes, the Perseids. And the Leonids, the big shower that happens every 33 years. That's the one from Comet Tempel-Tuttle. Mm-hmm. Tuttle was a busy guy, I guess.
Yeah. Hey there, Creamers. Yeah, Creamers mentioned the Leonids. Yep, very good. Yeah, those are coming up.
The Leonids 20 years ago or so were the second most impressive thing I ever saw in the sky.
I saw one Leonid that left a beautiful green trail, the color of this right here, but for very different reasons. Left a trail, what we call a train. Okay, we are going to pause it here. After that last photo, we have 37 done here. All right, and this is going to be Comet K2, Pan Stars. All right, and now we can save it. Now, for those of you who don't know, as we save this, you'll see a green bar appear up there. There it is. And we're saving this in an astronomical file format that requires processing, but never to worry, because you don't have to worry about that, because we're also save it exactly as seen. So you'll get it as a ping file. Just double click on it, and you'll be able to get that too. And what's happening when I say save is it's going up to our online database. All right, and our online database is available by going to this location, skytourlive.com, and skytourlive.com will show you the way in. It's our portal. It's the way into all the data, and it's the way in to see all the pictures and get prints. It's just a great site. All right, you scroll down a little bit, and it takes you right to the online server that is free of charge. You just peruse, zip on through, take what you want. The directory you want is the processed directory. Thank you, Izabela. She put the link up there. Thank you very much. And it's skytourlive.com and skytourlive.org. Whichever one you go to, you'll get there. All right. So there. We've done that. So now what we can do is say goodbye to the comment for the moment. And we'll clear it. And
this may be our last look at the comet.
it may be.
Hopefully, but
Dock that up there.
hopefully not. But never can tell.
Yeah. Okay. And so now what we'll do is come back up here. And the most important line here, this is the exposure time. And then this is the gain. Now, we only took this comet at 150 gain, meaning it's very, very fairly low sensitivity. Generally, we take it higher, but I wanted to take an image without all the grain or the noise. So this is a low noise image, and the comet was bright enough so we didn't need so much. Okay. But, so now if we go here and do a 1 second exposure, and I go into what I call my night vision mode, all right, you'll see this is as a 1 second exposure. All right, you see how noise changes? See that noise you see changing in the background there? Whatever you see changing, that's the stuff that gets averaged out, right? Because exposure to exposure, that's all different. But the stars and the faint nebulous clouds and the comet, they add up, and they get brighter and brighter and brighter as we let more images stack on top of each other. And that's what we do. And now we're going to go down to our actual size, where we actually make the whole sensor of the image fill in one frame. So it's 4 full moons across in size and 3 full moons tall. So it's just over 2 degrees wide and 1.5 degrees tall. That's the size of our image. Okay.
Mark, Alanis Brown has a question of you.
Oh, well, first of all, hello, Alanis Brown. Hey, Mark, I noticed that you look at a lot of stars and nebulas, but do you look at planets too? Are you able to see exoplanets with this stuff? No. Asking if we can see exoplanets. Exoplanets are the tiniest objects. They're hundreds, thousands of times smaller than the smallest star image we can ever see. So we could not hope to see those. Great question. And again, I just pointed out, which I guess I didn't see your question, but it's perfect. At 4 full moons across and 3 full moons tall, this is a wide-angle view. When we zoom in, we can zoom in pretty far. Okay, I'll show you. This is 125%. It's 100% right here, actually, of our view. This is 100%. This is the native size of our sensor. Okay. Well, as you can see, the stars look great, all right, but the planets are actually relatively small because this is a wider angle telescope. If we were to convert it to its original settings, because we converted it especially for doing this wider angle, fast photography, if we left it the way it was, then we'd be able to see planets, but we wouldn't be able to see things like this very quickly. That's the thing. We traded the quickness of the response, the quickness of the sensor, for magnification. All right. The telescope is running 25 times faster than it was before we modified it. And then those modifications were due to Starizona down in Tucson, Arizona. Good people. There goes another satellite, moving slowly. Now, see how it moves in 1 second, it moves that length? There's a lot of information buried in there. Based on that, based on the length of the trail, we can determine a number of things. Based on the length of the trail and how far across the sky that length of trail goes. All right, which we can measure. We can actually measure that. we could determine how far away that satellite is and what its orbit is from this. I have a program that does that. So that's pretty cool. I wanted to know one day, so I just wrote it. It's not so hard. Okay, so let's go back now to here. The moon is just setting now out there. Now, what do you want to look at down here? We've got so much to see. Oh, I know what I want to do. Now that we know the moon is going down, I want to go to DSO, Deep Space Objects, and I'm going to include additional catalogs. The Caldwell catalog, the Barnard catalog, Sharpless catalog, and then Lynn's Bright Nebula catalog and Lynn's Dark Nebula catalog. And that will give us plenty of fun things to look at. That never stops. So let's go find one now.
Danny, your question, it pertains to what Mark was just saying to Alanis a moment ago. This telescope is not really suitable for looking at planets. It's a low power, wide field of view, and planets are intrinsically very small. You need a high power and relatively narrow field of view to see them to advantage. We have looked at Saturn a couple of times, and you can make out the shape of the rings and a couple of moons, but that's about it. I bet we might take a look at Jupiter sometime soon. Jupiter is bigger and brighter than Saturn, but you still won't see very much. It's the wrong kind of telescope for looking at planets.
Yeah. That's true.
I have a refractor telescope. It's a long, relatively skinny telescope, and it excels at looking at planets, but it's for visual use only.
Yeah. You see the telescope is moving over our head right there. We're going to go check out this area we did the other night. We'll do it again. This area has some absolutely stunning nebulae that are so worth looking at. Now, the waypoint star we're using is Caus Boreal. I'm hoping that one... some of these stars have the wrong values in the database, which I have no control over. So sometimes we end up having to just drive it over, but I don't think we have to this time, because there is that nebula we're looking at, and there's the other thing I want to see. So the telescope is lined up really well right now.
Have you focused yet tonight?
I focused earlier, but I actually want to do it again. Yeah,
I know you're getting quite a temperature change from high to low.
Yeah. When
I looked at Weather Underground for the observatory area.
Well, the actual temperature based right here, you can see it. It's 33.56 degrees Celsius. All right. So what I'll do is, and that's actually good to see. You watch how this goes. So I'm actually going to defocus the telescope just a little bit, and you'll see the stars look blurry and soft right now. Okay. So what we're going to do now is we're going to use a focusing system that will autofocus our telescope for us. And this is very important to do at least twice a night to make sure. And I have a algorithm I developed that will, or coefficients I developed, which actually allow us to capture the trend, how the focus changes as the temperature changes. And that helps us. So we're going to scan in here, and you'll watch down here, it's going to build up a curve. And that curve it builds up is going to be U-shaped. In the middle of that U will be the central focus point of the smallest star image. So now we're taking, as you see up here, it's saying 3 of 12. And it does 12 tests. And within those 12 tests, it takes a single star and a bunch of, actually it takes all these stars, and it averages their size and figures out which size will, which position minimizes all of the stars the most. All right, and that is going to be the point of best focus. And what you'll see is this curve right here. You're going to see this thing moving down, then it's going to go up. All right, and as it goes up, that you'll see a second line appear in the middle of that, which is going to be the best focus point, at least for that moment in time. Then it will do a final one as it gets to the end. As it gets to the end of things here. Okay, you can see how this curve is changing now. Now I'm starting to go back up. So you're going to see a second line appear right about here. There it is. And that's the best focus point. And we are just there. And there's a curve of best fit. And then we'll say best focus. And then the focuser will go all the way back out and all the way back in. There it goes. It went out. And then it's going to come back in. There we go. And now we have a perfectly focused telescope. And the proof is when we zoom in. So
Mark, I have a question.
Yeah.
Not to detract or distract you, but
You know.
there was a tiny little object that was at about 8 o'clock in the center of the lagoon, down toward the bottom of the screen.
Okay.
Have we looked at that before?
I don't know. Down here?
That thing? No, 8 o'clock, right at the bottom of the
right
screen.
here? Oh,
Just
the bottom
left
of the screen.
left the center at the bottom of the screen.
This here?
Yes. Is
I think
that
that's a
thing we
cluster.
looked at the other night?
Yeah, that's a cluster.
Okay.
Yeah, here, watch, I'll show you.
I was just curious.
Yeah, see, that's like a cluster. I'm not sure if it's a globular cluster. It might be. We'd have to look and see.
All right. Carry
Now,
on.
give me an. Oh yeah, sure. No, that's a good question. Because if you're thinking it, other people are wondering too, probably. Right, so when you look at this, guys, what you'll notice is that this nebula has lots of dark stuff in it. That's actually the dark dust. In fact, I've told you this many times. The dark dust is my favorite thing in the universe, because lurking in those shadows is the seat of life in the universe. That's where life comes from. That's where stars come from. And that's the stuff planets are made from. And that dust comes from exploding stars. It comes from stars that have not exploded, but ejected their outer shells. It's really amazing. So what we're going to do now is, I just don't know where I want to begin. I'm going to take this out of the view. I'm going to go down. So I'm going to bring us up a little bit. Okay, when I bring us up, it takes about 13 seconds, 11 to 12 seconds actually, for us to get our guide star. Now this little edge will be off, but I want you to see this. Okay, and let me go down a little more, because let's see how far I have to go to get the Trifid Nebula in here. Probably it'll put too much of the lagoon off the view, maybe. And right above this, and the Trifid should come in. There it is. It's right there. So if we go a little more to the west, you'll see this other nebula up there. So they're just not quite able to be in the same view. But you'll notice this dark thing. That's a dark patch of dark nebula, which is dark dust. All right, so we're going to bring this back up. And then we're going to move this a little bit to the east. There we go. Actually, you know what? I got to actually bring us back to auto frame. Okay, so there we go. So now we got that. And now what I'll do is head west just a little bit more. One jog. Okay, well, maybe 2 jogs. Okay. Now, we're going to let this acquire a guide star. Right? And then we'll take the shot. Nope. Gotta go a little more. That's good right there. Okay. Okay. All right. So there we go. We got our guiding going right there. You see the numbers changing. That's guiding in the right ascension, east, which is east-west, and the declination, which is north-south. Okay, it's doing both at the same time. Okay, now let's do a simple 30-second photo here. All right, 30 seconds, and we'll be right back to that in a minute. Oh, I can't change that yet. All right, we'll go to our live stack, get rid of the last one. That was the comet that we saw. That's up in the database certainly by now. So if you want to go see it, you can go to skytourlive.com and check it out. All right, so we're almost done with our first 30-second shot, and you'll see it right here. And okay, now watch this. Wow. Where else can you see this kind of stuff in 30 seconds? Wow, that's just beautiful. I'll tell you what, that's actually worth hanging out with it for a while. So what we're gonna do now is we're gonna pull that in, right, and leave it here for a while. Oh, look at that thing. Wow. So this area right here, this is called the Chinese Dragon Nebula. And I'm not sure where the dragon's supposed to be. It might be this whole thing down to here, which may very well be. But you see this dark nebula snakes all the way around throughout this whole region. Goes up there, comes around here, comes down there, down here, all right, down here, and it goes all throughout this cloud of hydrogen gas and obscures some of it. You can see that pretty effectively here and here. It's effectively blocking what's behind it. Well, Prow, it does elicit these kinds of comments, doesn't it? He says, I said, wow, the same time Mark did, right? Yeah, it's just a wow. I actually wish I could hear what you were all thinking when you see these things, because I'm really hoping you guys like this. Danny Johnson asks if the supernova is still visible. That's the one in NGC 47, is it 47, 46, or 46? I can't remember, Daryl.
Say again?
Mute. The supernova, was that 47, 46?
46, 47.
Dyslexia. I don't dyslexia have.
Yeah. Neither me.
Oh. It's gone now, though. We can't see it now.
Yeah, I was just typing that out, so I'll erase it. However, Danny, the second part of your question, what the web can look at is not necessarily when we lose the comet, when we lose an object here, it's still visible. In fact, it may be more easily visible to the web. The web has an unusual field of view. It's we've talked about this. I think it's sort of a donut or a torus shape around the telescope at any one time, and it may be coming into a better view for the web. I wouldn't be surprised, but the supernova is definitely on the wane now. It'll be going away. By the time Virgo comes back in the morning sky, it'll probably be gone.
Yeah. Let's turn that off for a minute. Let's zoom in a little bit and see what we got here, shall we? Wow. This is the Lagoon Nebula, Messier 8, and it is probably one of the most phenomenal locations in the universe. It's a stellar nursery. This is a young hot cluster we see here that did form in here, but the nebula itself, in addition to these stars, is powered by a star that's buried in here. And to show you that, I just have to take our processing bar, called our mid-level, and drop it way down. And then you can see that location. Right there. See that hourglass looking thing? Let's zoom in on that.
That's the hourglass.
Yeah. That hourglass location is the location where there is an O-type star. O-type stars are the hottest, youngest, and short-lived of all the stars. And this star puts out more energy in the ultraviolet than it does in the visible. So the fact that you see it gives you an idea just how bright it is in the other wavelengths. You know? Hey, Farva, thank you. That screenshot is worth another donation. Oh, thank you so much. Thank you so much. So, when you look at this, you'll see that that's what's going on there. That's the grand illuminator of this nebula. And then these young hot stars serve to help that too. Now let's go back to seeing all of this. Now you can see just what's going on here. Look at that. Wow. Hello, OG Skywatch. Thing about this O-type star is when it is giving off so much copious ultraviolet energy, atoms in these clouds, and the hydrogen atoms in particular, will absorb that energy, and primarily their electrons absorb that energy, and the electrons go into higher and higher orbits around the atom when that happens, until finally, bam, that electron disappears from the atom for a period of time. It's what's called ionized. And then as it loses energy being away from the atom, it comes back down into the atom, and as it cascades down to discrete energy levels in the atom, it gives off light. And the predominant energy level it goes to is the second level, what's called the n=2, go figure, level. And that is the reason we see all this red, okay? Because that particular light that the electron gives off is red light, and it's happening millions of trillions of times per second in this nebula, in this whole region.
Yeah, this is probably the second best thing to look at in the sky as seen from the northern hemisphere. I would say M42 and Orion is first.
The Great Orion Nebula, yes.
Yep, and M8 here in Sagittarius is second.
Yeah. You can spend so much time just looking through. We've stacked 16 of these so far. So let's take a look. All right. This is that Chinese Dragon nebula right here. Notice this squiggle right here, this squiggle of dark nebula. It's interesting. It looks like it's toothpaste, black toothpaste that was squeezed out of a tube. This is the result of complex motions in these big, vast clouds of gas and dust. And you'll notice right here, you've got this sharp edge and this curved front here. This could be a form of a shock front, perhaps, by something that was going on in here that we may not be able to see, pushing this nebular gas, this hydrogen, out. That happens as well. We see that a lot. And then we have these two stars in here, which are actually causing this reflection nebula. If you notice, it looks like it has these beautiful feather look to it. Okay, this is a stunning location. And so when we look at these nebulae like this, you're literally looking at the precursors to life being built by the universe.
Can you zoom in on that bright orange patch again?
Yeah, maybe.
Please.
Yeah.
You see in there what you touched on, what I often mention, sometimes we'll see a line of stars that seems to follow like a wavefront or something, and I think that may be what we're seeing right there. There's 8 or 10 stars in that line right there.
Yeah.
And they look like it's real.
Well, we'd have to see if those stars actually have distance values associated with them. Because if they are there, then it's possible that these stars could have been forced to form, And it's not really such a stretch to understand how stars could form like this. And the reason is because when we have a shock front moving outward, for whatever reason, sometimes a star has very powerful winds, or an ancient supernova pushes a shock front along. The star is long gone, but the shock front's still going. Nothing to stop it, basically. But when that collides with other, gas and dust in the interstellar medium, it pushes it. And that push could be the tipping point that starts it to collapse on its own. And that's why we might, I emphasize the word might see stars forming in a line along a shock front. Because maybe those stars were induced to form as this compression wave of this material pushed and snowplowed basically into other material in space and caused a compression which could have led to collapse of different clouds into gravitational discrete objects that became stars. And it's possible that planets form too.
My point exactly. That is so cool.
It is.
We've just recently started paying attention to the Chinese dragon here. I think this is a really cool sight.
Yeah, I mean, this was a gem hiding with the lagoon, which always took our attention.
Mm-hmm.
Yeah, because obviously it's worth your attention. Look at that. Now we've stacked 24 here, and we're gonna let it go to 25, and that's in 18 seconds, 15 seconds, and then we will move on to another object. Hey there, Just the Facts. How you doing?
I have a favor to ask.
Sure.
Could we take a look at that little object that's down below and to the left?
Yes.
Just a quick look.
Sure. Okay, we're gonna pause this, and I'm gonna call this what it is. This is Measure 8, M8, and Chinese Dragon. I don't know the actual designation of the Chinese Dragon. We probably should find that. Cosmic Ray says Stellarium needs to update with your images. Yeah, that would be great, wouldn't it? But then you wouldn't need us. Nah, just kidding. Bonnie says, new favorite. Isn't it though? Isn't it though? Wow. Farva, you say black goo toothpaste. Actually, I had a Japanese toothpaste that was a black goo. It was based on charcoal. And it was meant to be like a tooth whitening. I figured I'd give it a try, right? And it worked. But if you didn't rinse well, it looked like you had black in your mouth. It's like, oh, that's disgusting. So really encourage you to rinse a lot better.
The Chinese Dragon Nebula, it's like 3 objects in one. B303, which will be a Barnard object, the Dark Nebula.
Yep.
With NGC 6559 and Sharpless 2-29.
Yeah.
I guess NGC 6559 would be the main name for it.
Okay. Okay, now that we got our name here, we're going to save it. And now we have our raw file, and then we'll save it just like you see it here. All right, and now that I've done that, I'm going to push it a little bit and see if we can pull out some more details. Holy cow. Now we'll save that too. Okay, look at that. Wow. Could you ever imagine that's out there? That's just beautiful. Oh, man. I could put that up on the big screen and just stare at it all night. Because there's so much to see here. You see stars and planets forming in here. These black globules deep in the nebula that show up only under extreme scrutiny. These beautiful tangles up here of black dust, the edges fringed with blue because they're scattering the light of nearby stars, the blue light especially, making it appear blue-edged. And we call those reflection nebula, even though technically they're scattering nebulas, but they've been known as reflection nebulas. Something else, that's beautiful. We see them especially with the Pleiades. A lot of scattering going on there too. Really pretty. Okay, let's save this exactly as seen. I probably did it already, but we'll do it again. You can always have too much, but can't forget to save it when you must save it. And now we can clear this, although I don't want to. But it's already up on the server most likely, and if not, it'll be there in a few minutes. Or a few seconds, actually. So let's actually bring back the telescope. I want to see the telescope up there. All right, and we're gonna go up. While we're here, let's go check out. Well, first of all, let's go to our 1 second exposure, and then go to our night vision mode. Alright, here we go. There's night vision mode. Now you can see this is a 1 second exposure, and you can see some tremendous detail already. That's pretty good. And some satellites moving through.
Edward, I would dare say it's possible for that to happen naturally, and indeed it probably has. I would want to say if you look at that web image of the galaxy clusters, it may be happening. Is it possible for us to line up to and use them like a telescope? That's far beyond our capabilities.
And just to let people know what Edward was asking, he asked, is it possible to line up 2 gravitational lensing events and use them like refracting telescope to see even further? My opinion on that, though, is that that would be kind of tough, and the reason is because of the fact that when you're trying to magnify images with a gravitational lens, the lens effect tends to distort the images dramatically, and that would be hard to actually counter and reconstruct the original image.
Uber Crew has a question of you, Mark.
Hey Mark, how come there seems to be a dark band that outlines the nebula? That dark band is exactly what we talked about, Uberku. It's the dark dust, the same kind of dark dust that I'm about to show you. Okay, this is the Trifid Nebula here, and in the center of the Trifid Nebula, this is we'll zoom in on our 1 second exposure here just to show you. Okay, You'll see the noise changing as it takes pictures. This is the dark dust lanes in this nebula, and they happen to be over a nebula behind it, an emission nebula. They're all throughout it. Don't keep in mind that these dark nebulae are all throughout these emission nebulae. So there's no surprise that we might see them in front of it, because from every angle something is going to be out in front of it, because it's all throughout. And that's what this dark line is that you saw around the lagoon, the same as this. It's dark dust that's obscuring what's behind it. No, Uber Crew, that's fine. He says, oh, sorry, I missed what you said. That's fine. That's fine. Hi there, Asher Rial. How are you? Thanks for joining us. Make sure you subscribe if you haven't. Okay, what we're going to do now is we're going to start taking some pictures of this beautiful object. This is the Trifid Nebula. You'll notice there's a blue component up here, which is going to come in very clearly in just a minute. You're going to like it. There's a lot going on in this region. And I'm thinking, Daryl, that we're going to go to a 40-second exposure here to show the subtle differences in that black dust, or the brown dust, and the blue.
Okay.
All right. So here we go. We're going to come out of night vision mode and go into live stack mode. And if you're wondering when the exposure will be done, you just have to come over here and look at this little bar. This bar here is going to show you the progress. And if you're just joining us, this is our camera control system, and over here is our telescope control. There's the telescope in the building out in Arizona. That's the telescope computer, and this is the telescope originator. And
Mark, I see. I'm sorry.
Yeah, go ahead.
I see your gain is still at 250. Do you think that's enough?
Yeah, this will be fine. Hello, Hunter. Yeah, I didn't give it enough time to capture a guide star. I kind of knew that was going to happen, so the next exposure will be perfect. I think 250 will be good. It's a good combination, a good... I did raise it earlier.
All right.
I don't want to go to 350 because that's going to be a little too noisy.
Right.
So we'll try 250 and see where that sets. We can always bump it up.
Yeah, well, we've been looking at bright stuff so far. So.
Yeah, I mean, look at this. This is really bright, but let's bring it down to size here. And we still have a little bit of issues here. Let's try this again. I want to try and get a perfect shot here.
Scott, it's a Meade 10-inch Schmidt Cassegrain with a Hyperstar system, so it's working at f2, which is what's giving us the wide field. And it's a ZWO Astro camera. I forget which one. Mark can tell you.
ASI 294 MC Pro was the name of the camera. Okay. All right. I'm going to go into our Starlock system here and make a change.
What happened?
I may need to change the declination rate here, which is at 17 right now.
Think it might be wind?
It could be, but I'm going to go to 20 just to test. All right. Okay, so let's go back. Clear. If this comes out mostly right, then we'll leave it at 20. We'll clear it one more time and just start taking pictures. Oh, you're in Gilbert, Arizona. Hey, that's pretty cool because the person who is one of the fundamental people with SkyTour Livestream was a police officer in Gilbert. Okay, yeah, this is gonna be right. Look at that. Now, first things first. Let's color correct that. There we go. Yeah, that's pretty. Now, in this next exposure, what you'll notice right away, which is why I'm leaving it zoomed in here. See this color spotting here, this modeling? Watch how much of it goes away at this very next image, okay? This is what stacking does for you. All right, ready? Watch right here. There it goes. You see that? A lot of it went away, and it will keep doing additive processing like that, additive processes to remove that noise as we go on and on. This is the Trifid Nebula, and the Trifid Nebula is an emission nebula of hydrogen gas that's doing the emitting, plus it's a reflection nebula. The dust in here scattering the light from stars in here, possibly this star. I'm not sure it's that star. It might be another star here. Could be that star. Depends how far away they are. Wow. Yeah, Scott Steers. Hot in Bortle 7 in Gilbert. Yeah. We're actually at Bortle 2.5 or so at this site. You can't see your hand in front of your face. That's about 65 miles west of Phoenix. What I should do while we're waiting for this to come in is I should try to see if my camera... Okay, it sees our camera. Let's try and capture a shot here. Last time I tried this, sometimes this camera gets interfered with. This is our all-sky camera. So let's see if we can do it. We'll just briefly put it over the whole screen. Okay. No, it doesn't. It gets confused. Well, I tried. It gets confused sometimes because I'm doing all these other things. It can't acquire basically a slot in which to put its data, basically. So the camera just keeps counting up. It doesn't ever get stopped. It doesn't get seen. So right now the system saw it when I started, but when I started taking the picture, it lost the camera because this is taking time and hardware. This is taking time and hardware. This is taking time and hardware. The focuser is taking time and hardware. It's really quite something. Look at this beautiful dark. These are beautiful. Now, I did 40 seconds. You can see why now. See the color of this stuff here? You can see that this dust is not just black dust. It's actually brown. And that's really more the natural color of interstellar dust, see? And it's because it's silica based. It's got a lot of silicon in there. There's a lot of carbon in here as well. We have molecules of carbon, carbon molecules, carbon tied to carbon. We have silicon in there. And the dust is actually, what happens is the dust particles that form, they grow. They grow when they acquire other things on top of them. So basically what they acquire are ice, but methanol, formaldehyde, carbon dioxide ice, water ice, all right, and they form a sheet over these particles, all of which will serve to scatter the blue light. But then when a hot star hits the dust, it could, if it's, got enough energy, it could melt that ice. And then this nebula, this dark dust cloud, is not just a grain of silicon with a bunch of ices locked on its surface. It's a grain of silicon. It's a grain with methanol and formaldehyde and carbon dioxide, carbon dioxide, and other elements and compounds that is now a slurry of planet building stuff. And amid the overwhelming abundance of hydrogen gas that's all throughout here as well. Hydrogen is the most populous element in the entire universe. That's followed right behind by helium. And next most abundant in the universe is oxygen. And then finally, number 4 is carbon. So it stands to reason that we're carbon-based creatures, because carbon is an extremely flexible element. It bonds with more things than any other in the entire periodic table, way more than silicon, and unlike silicon, carbon bonds can be broken and remade. Silicon, very tenacious. Very tenacious. You can't, when it makes a bond with something, it tends to make a crystal structure, which is very well locked together, and it's hard to break apart. And there's very few chemical reactions that can break it apart. So carbon, on the other hand, is sort of the granddaddy of all elements in the periodic table. So we tend to think of carbon as the mainstay of life in the universe. Now, I'm an astronomer. That's what I went to school for. That's why I talk about the things I do. This is what we look like. If you look at the abundances in the universe, the periodic table doesn't really reflect them by just looking at the table. All right? So it's not a table in order of abundance in the universe. It's a table that is built for a very bunch of different reasons. Okay? Give you an example. The columns, the up and down rows, okay, the up and down in there. If you look where carbon is, right? Carbon is right above silicon in terms of the next one down. And that column is elements that are most like each other. So underneath carbon, the next most likely element like carbon is silicon. But they each have their quirks, right? Silicon's quirk, as I mentioned, is it just bonds too tightly, and we just won't get bonds that can vary with enough flexibility to support a vast life strategy. So silicon is out, to be honest. I know people say, "Whoa, silicon-based life." Yeah, not likely. Not likely. Certainly not complex life. Maybe there could be some kind of simplified microbial life. I don't know. And we didn't know about chemosynthesis until we found bacteria that gain energy in complete darkness by using chemical processes. So maybe silicon could be doing something, but complex life, yeah, I would stake my entire reputation on the fact that we'll never find complex life that's silicon based. I mean, people do have pet rocks, right? So hey, Look at how this nebula is coming out, guys. This is after 12 stacked images. Gosh, this is beautiful. What do you think of that, Daryl? You're on mute. You're still on mute. Oh, okay. Yeah, he said, "Excuse me, be right back." Sorry about that.
Ta-da.
There you are. What do you think, huh?
Oh, I think it's beautiful.
Yeah. Now I'm going to back out and show everybody what the whole region looks like. Because this is not the only thing that's here. It's sitting in the midst of a lot of other nebula. Look at the overall view. Now, if you want to see what's really here, we're going to do this now. We're going to actually bring our mid-range slider into the data curves, intercept more data, and show you a little bit more about what's there. Look at that. Now, we overexpose this a little, but look at the red emission nebula. These are called diffuse nebulae that are here. These are star clouds, by the way. Those are all stars. Those are all, suns, basically, if you want to think of it that way. Not all of them like our sun, but you're looking at an awful lot of planets out there, actually. Let that sink in. This one tiny 2 degree by 1.5 degree field is showing us an awful lot of planets.
Per Uberku's question a little while ago, Uber, when you look at that, maybe you get an idea that how big the dark cloud is and that the few stars that are illuminating the lit portions of the nebula are just like shining like candles inside the smoke.
For the blue one, yeah.
Yeah, well, the red is hydrogen emission, of course, and the blue is reflection nebula. But maybe that will give you a feel for how much dark stuff there is all the way around it that's just not being illuminated.
Yeah. See, the thing is, what Daryl's alluding to, okay, this star right here is one of a couple that are in here, and they're responsible for making this nebula glow. And you'll notice that the glow only goes out a certain distance. Why doesn't it glow further? There's hydrogen out here. Undoubtedly, there's hydrogen out here. So how come it doesn't go out further? It's because the energy of the star, okay, the intensity falls off as the square of the distance away from the source. So what that means is that if you go twice as far away, it's 4 times less intense. Okay, go 4 times as further away, it's 16 times less intense. So that means that there is going to be a certain point where the energy isn't intense enough to cause the to cause the elements to ionize. And that makes a logical sphere, basically, an ionization sphere of ionization potential that's all around that one area. Beyond that, you can't do it because there's not enough energy to do it. But these nebulae, these reflection nebulae, you notice how these have sort of a shape to them, and these are sort of irregular. Well, the dust, this blue is actually dust. Okay, it's this same as this black stuff, but this black stuff just happened to be denser here, or more toward us, or more in out of the starlight enough, so that it didn't scatter the starlight. Because this is undoubtedly between us and that star that's illuminating these things, because it's dark. That's the shadow side, where the density of the cloud prevents the cloud's atoms from scattering blue light in our direction because it's so dense there. So these stars here are all part of the entire region. Again, I'm not sure if it's this star that's causing this to be scattered here or not, but it does go all the way around. So it might be a star we can't even see. Or it could be from these stars right here. Don't know for sure. But these stars here could be also causing dust in this region to scatter its light, but it's overwhelmed by the sheer amount of hydrogen. See, it's all about density. The density of the dust in this region might be less than the density of the dust in this region. Certainly this dust is more dense than here. But even at this density, you're only looking at about 10,000 atoms at the most per cubic meter, or cubic centimeter rather. So that's not a lot of atoms. When on Earth we have like 10 to the 19 atoms in the same amount of space. So it's really quite a difference. So if you went into that with a spacecraft, you might just go sailing right through it and not even know you were in it. So OG Skywatch says, what if the silicon life was created like AI or a meta being, aka person uploaded into electronic von Neumann probe or data from Star Trek? Okay, the question means, what if the silicon-based life form was actually a AI creation, possibly? Or a life form that's uploaded to an AI. Well, sorry, I just yawned on you. That's beyond our capability, but not beyond our imagination. So right now we could say we can't do it, but it might really exist. It might be, but we don't know. Actually, if you think about it, alien beings would probably, as we have, create life in their own likeness, or create robots in their own likeness. We did it. the space station has a creature, on it that's a robot that looks like a human torso with a face and a golden visor, with arms. All right, and that again. Look at what Boston Dynamics is doing with their robots. They have robots that have legs and arms and walk around and stack boxes. All right, so the things that's interesting is that if we're doing it, then perhaps alien beings are doing it too. Forbidden Knowledge says, great night for sky watching. Yeah, it really is. Thanks for coming, by the way. Look at this, man. I'm really loving this. I don't know what it is, Daryl. We've taken pictures of the Trifid before, but how come now the Trifid looks so much nicer than we've ever seen it?
Really, it probably doesn't. It just, you're seeing it again, and seeing it with fresh eyes, and it's standing out for you. It's looked this good before.
I can show you pictures we've taken that we thought were great, and
yeah, it may just be the way the settings are in the imaging. It's always been there.
I know that, but I think that our system has not been able to keep up with it or make the best out of it, and now we can do a lot better. All right, let me take us back out just to look at the entire frame before we move on.
Can we take a look at that little thing below the lagoon?
Oh yeah, you asked about that, didn't you?
Yes, I did.
Sorry. Okay, let's do that. All right, so we have taken 26 frames. We'll pause it. We'll save this after I renamed it already. Okay, good. So this is the Trifids. We're going to save that. There's our raw file, and then we'll save it exactly as seen. So there's the ping, and if we were to click on it, here's what you'll see when you click on it. That's what you get. All right? So you'll see it just like we captured it. All right? And that's the file that's saved to the database, so you can have fun with that if you want. All right. So let's get out of this. First things first, we're going to dock it and get rid of it, and we'll come back to wipe it out after. Now we'll go to our 1 second image intensified view. Okay. There we are. And now Daryl has requested that we look. Hey, Rising Phoenix 1, how you doing? It's nice to see you back. Simon, hi, good to see you too. Okay. Rising Phoenix says, long time subscriber, longer time lurker, first time chatter. Because that is so gorgeous. Well, thank you so much. I'm glad we could draw you out of the shadows. The shadows are my favorite part of the universe, by the way, as you might have heard me say. Okay, let's go ahead and first of all, let's move down a little bit. And then let's go and change this to just a little bit faster speed. Now we'll move down. Okay. All right, and then we're gonna move over. Okay, Daryl, this is Daryl's object.
Well, just take a quick look.
Yeah, that's all right. Thank you, Izabela.
Thank you, Izabela.
Okay, so this is a cluster underneath the lagoon. And
I think that may be a little more in a cluster.
no,
I see some emission nebulosity in it.
maybe, or it's a distant globular.
Looks red.
Yeah.
Oh, that might be a globular. Can you pull up Stellarium?
Yeah, I can. Let me just first start the exposure. Okay, so we'll go from here, and we'll do a 20-second shot of this. There we go. And then we'll go into our live stack and clear the previous one. That'll be up in the database in no time at all. Make sure you go to skytourlive.com. And where is that? Well, that is right there. No, that's not it. That is... this one right here. There we are. skytourlive.com. Alright, skytourlive.com is the portal to all of our data. Wow, look at that. Look at those beautiful star clouds down here.
Uh-huh.
Just beautiful. And we'll wait for the second one. We got 2 already. Alright. Now let's go into Stellarium and see if it's here. Oh, look at that. Is that the starfish cluster? It's a globular.
Yep.
Ta-da!
Nice.
Yep. Not bad.
Say how far away it is. It's awful small.
Yeah, it has some reddening to it. Let's find out. We're in the starfish cluster here. Oh, it is. Well, it says it's, I don't know if that's correct. It says 9,700 light years. That's rather... I'm not sure that's correct. NGC 6544. If you want to look it up and confirm that. This planetarium thing is fantastic. But it's been known to be wrong.
What was that? 6544?
Oh, yeah, let me, sorry. Yeah. 6544. What do we got?
Small globular cluster visible in Sagittarius, magnitude 7.5, 7.5, diameter 1 arc minute, less than 1 degree southeast of Messier 8th Lagoon Nebula. On the edge of a rich star field.
Yes, it is. Right there.
Doodah. 9,450 light years.
Okay, so Stellarium is right.
Yeah, pretty good agreement.
Look at that beautiful star cloud down there, huh? Wow.
So it is intrinsically small. Pretty.
Yeah. Okay. Let's see what else. We've been hanging out in this area for quite a while, so... oh, this is that beautiful nebula that shows us these gorgeous colors. You want to see that, or you want to see something else?
Go for it.
Alright, so we'll go there. This will be IC 1284 index catalog objects. 1284, it's a H2 region, that is a hydrogen, ionized hydrogen region.
The area just to the upper right of it really stood out in Stellarium. You know how they do that when they fill a field, like there's
Yeah.
things of note there.
Yeah. Okay, we're gonna let this one develop. This is actually pretty. We did 13. This is NGC. What was it again? 50. Dang.
Give me just a second. 6544.
Okay. Oh, come on. And we'll call it a GC for globular cluster. All right.
Can we zoom in on that before we leave?
Yeah.
See if we see why they call it starfish.
Well, maybe if we go more into the core, maybe it has these appendages sticking off. Maybe. Maybe. Wow. So many stars. Okay, we'll pause this and save it here. This is just beautiful. Okay, and we'll actually clear this one now.
Izabela just renamed 10 files starfish instead of what they should be named. Ryan DeBoer asks, are any stars visible in daylight with binoculars? Stars may be Sirius. There are planets certainly you can see in daylight.
I used to show people Venus during the day.
Yep, so have I.
And once you find it, you can't take your eyes off of it. You won't find it again.
Yep.
It's really good. Okay, so this is going to be our night vision mode.
You can see Venus without binoculars.
Yeah.
If you know where to look.
That's correct.
And possibly Jupiter as well. Venus is the easiest.
Yeah.
Yeah, God, look at that star field there on the right.
Yeah.
That's huge.
Yeah, this is... Actually, isn't this like the Sagittarius... Small Sagittarius star cloud?
That's one of them.
It is. It's the small Sagittarius star cloud.
Okay.
So we'll put this to the lower left and put that in the right and just see the contrast. Okay. Alright, so let's center you up. Alright, and you can see the size of our field here, which I didn't mention to you, but that square red box, that's the size of our field, and the angle, the orientation. So let's go here now, and then you'll watch the stars move here in a second. Okay, here we go. Zing! Away we go. We're going to go to a star that will be a waypoint star. That's probably it. And it's going to tell us which star it's going to right here. We're at 75% of ours. Okay, it's going back to Caus Boreal.
Top of the lid of the teapot.
Yep.
It's also the northern tip of the bow that Sagittarius the Archer is shooting.
Yep. We got that. We've got that. 2 globular clusters there.
Yep.
Now up we go. And here it is. Here is that star field that we were talking about. There's the nebula. We're going to put the nebula here. And so you can see this gorgeous star field impinging on this. And you'll see what I mean, how beautiful this is. So that means we're going to shift ourselves to the left a little bit. Before I do that, I'm going to do this. I'm going to go back up. And go into this just to watch. Okay, here we go. So now, let's bring that star cloud in. This is good. This is that music I think sounds like Stargate SG-1. For those who saw Stargate, Ryan, that's okay. Ryan DeBoer, where are you located? I knew a Dennis DeBoer. Okay, that's beautiful. I'm gonna just give us a little northern push here. Hey, C&D boy. Good to see you, man. Move this over a little more. Okay, Ryan. Thank you. Okay. Look at that interesting shape right there. Let's see how that plays out when we actually do our 30-second shot here. Okay, we'll come out of night vision mode, go into our live stack mode. It'll be black because I cleared it already. And we'll see what it looks like. And this is IC 1284. This is good music for this one too. Oh, look at that. Wow.
Cool. Colors down at the bottom look unreal.
Yeah.
Looks almost green.
Down here?
Yes.
I don't see green. I mean, red. This looks red to me.
I see some green in there too.
Huh. Notice this is that black. This here is all black. All these black, beautiful clouds here that are moving through. Wow. Just amazing stuff, I'll tell you.
Got one little wisp of dark cloud above center.
This here?
Yes.
That's really pretty. Let's just see what we got here. I'm going to soften this view a little bit to help see some of the details in the dark. We'll change that. Look at that, now we're seeing detail in there. Wow, this is cool. The universe is a magical place. It's almost like we're on a river of black dust, and this little peninsula sticking out is an island. Of Stellar Nursery. A Stellar Nursery island, or a Stellar Nursery peninsula. Yes, this is the scope, Donald, not the planetarium. Islands in the stream, yes. Yes, this is something else. We got these two little islands of blue reflection nebulosity here, which tells us that stars are buried in this black dust here.
Islands in the stream.
Yes.
Dolly Parton, Kenny Rogers.
Islands in the stream. That is what we are. Yeah, something like that.
Yeah.
Yeah.
Look, that was Dolly and Kenny Rogers.
Yeah. Cosmic Ray says the way it looked 2,185 years ago. Is that the distance to this nebula cosmic? I'm assuming that you looked that up. IC 1284's distance. IC stands for Index Catalog. There's a bunch of catalogs. We have Caldwell, Vandenberg, Sharpless. We have Malat. We have, so many different kinds. Lin's Dark and Bright Nebulae. Messier Catalog. New General Catalog, NGC. So very, very large number of catalogs compiled over the years. Many of them are for specific things like Galaxy Cluster Catalogs or Open Cluster Catalogs or Variable Star Catalogs. Let's why don't we just give this a bit of a, like that, and then let's bring it in. Let's bring it in for everybody to see. Okay, go ahead, push it out there. There we go.
Taryn wants you to save this image.
Oh, I'm not gonna lose it. I promise. I'm gonna save it. This photo will be saved, Taryn. Just take that down for a minute. Wow.
And you set all the stars to the upper right or to the right or the small Sagittarius star cluster.
That's correct. Let's see how much I can reduce this in size. Not much. That's it. That's almost our full frame. I do want to zoom in like right in here because I want to show what's going on here. Look at this right here. Look at that beautiful little C-shaped dark nebula. Now what's going on in there? Maybe nothing, maybe something. Why is it a C shape? It's a C shape because something pushed it into that shape. And it doesn't take much to start a cascading process by which gravitational collapse can start. That's where stars come to, like these. They came into being to actually ionize the hydrogen gas in this location and cause this nebula to glow here. These stars are just scattering the blue light, these stars are having their blue light scattered by the dust clouds that they sit within. And this is the range over which that scattering can occur, obviously.
That's like I mentioned the other night again, the dark lines, are they all real or not? It's like me and when I saw those spider leg shaped
yes,
dark lines, but they're just below that C you mentioned. Yep. There's kind of like a wandering line running left to right, just below that right there. And it meanders on down to the lower right some. And
well, it goes down here.
Others that right there, and another below that.
I think this is very interesting right here, this little spot. Zoom in on that. Now I can see that our guiding is off a little bit.
The other object just to its lower left, the brightly lit white area, that looks awfully familiar. Didn't we look at that the other night?
Yes, we did.
That dark spot right there?
Yeah, I was thinking that might be maybe a Bach globule. Now, we see two stars there. Maybe at some point we're going to see three. because this is a gravitationally condensing blob, most likely, and it's probably going to form a star first, followed by planets if there's leftover material, and it'll all form at the same time. But if there's enough to form a star and planets, then we'll get those all at once. Look at this right here. What complexity, huh? This is complex stuff, guys. Complex stuff. Okay, we've done 17 of these, so I'm going to pause this, save this, save it exactly as seen, and then do something crazy. I'm going to start another exposure of the same area just to see if I can get these stars better. Let's see how these look. See how noisy this is? Watch how the noise goes away on the next exposure. Remember how clear this globule was on here? So we got 3 seconds, and now watch much of the noise go away. Look at that.
Yeah. That little dark globule looks almost... At first it just looked like a spot. Now it almost looked for a second, I thought, like it has kind of a tail to it hanging down at 6 o'clock.
Well, it actually does have an illuminated portion to the upper right.
Yes.
That's something that's been there, which is kind of neat. You know.
Can you zoom in anymore?
Yeah, let's wait for it to catch up, catch a little more, clarity, get rid of some of the noise. But yes, we can.
All right. Did you start another image?
Yeah, I did.
Oh, sorry, I was too busy looking.
That's all right.
Yeah, I thought it looked almost like a tadpole there for a second.
Yeah, it did, didn't it? Okay.
I remember last year, I guess it would have been the first summer since you opened the observatory in Arizona. We just spent a lot of time wandering up the Milky Way along the edges of the Great Rift and just finding countless dark nebulas.
Yeah, this was one of those areas we had found. A little tide pool of the universe. No? Who knows how much is going on here? There's planetary formation going on for sure. New stars will be formed in there. When they're first formed, they actually will make this nebula most likely. And then as their radiation pushes that hydrogen away and the stars migrate away from each other over millions of years, then they're left to their own to actually do whatever they're going to do. And by that time, their planets will have formed, and they can then have a potentially long life, which I think is really cool.
Small Sagittarius star cloud is also known as Messier 24. I should have known that. I probably did know that at one time. 600 light years wide. It's about 10,000 light years away. 10,000 light years away.
Which is consistent with this nebula and these blue reflection nebulae being much closer to us.
Near
That's
the
much further
nebula.
away.
M24 is one of only 3 Messier objects that are not actual deep sky objects. 10,000 to 16,000 light years.
I'm going to go to 10 on this one. And just save it to the same place. Okay, we've got 10 saved there. And we're going to pause it, save it, and then save it exactly as seen. So we're going to have 2 directories underneath the IC 1284. Let's just take one more look up close here. Wow. You can see how this globule is actually an ellipsoid object, and it may have a slight tail going down to 7 o'clock, which means it could be getting eroded by another bright star that we can't see. So,
You know, I see a very faint tail-like thing at about 6 o'clock.
I see what you're saying.
When you
but
zoom in, it is more like 7 o'clock.
yeah, this is what you were seeing. That's what I was seeing.
Yeah.
That's in line. That might actually be another star, and then this is the globule. Really interesting. Let's see if
And there, yeah,
let's see
that
if it-
whole reflection nebulosity right there. There's a bigger one down at the very edge at about 6:30 or 7, and a couple more over at about 9 o'clock or so,
yeah.
and some smaller ones there at about 8 o'clock.
Yeah, it'd be interesting to see this thing in more detail. All right. Well, this was a good exploration of this. I did a color correction, and I'm going to save the image again, just so you can have it. And that's for Taryn Marie. Of course, you can all take the image, of course, but Taryn asked for it specifically. So we'll save it exactly as seen.
Robin, what's the definition of a deep sky object? Question mark.
That thing.
Deep sky objects can be a number of things. They can be star clusters, open clusters, or globular clusters. They can be nebulae, bright or dark nebulae. They can be galaxies. They can be planetary nebulas. Stuff like that. They're discrete objects. I assume that's why they say the small Sagittarius star cloud there is not truly a deep sky object, because it's not one object. It's many thousands of stars all clustered all together. Probably be wrong to call it a cluster. It's part of the Sagittarius Carina spiral arm, like the
Part of
next
the
arm in.
galaxy.
Yep.
Okay. Okay, now this is our night vision mode, and let's bring the telescope back so I can see what I'm looking at.
Suggestion?
Yes.
Troll north in the star cloud a little bit.
Okay.
There are a couple of very distinct dark nebulae inside the star cloud, or in front of the star cloud.
Okay. Let's try that. All right. First things first, we're gonna just. Okay. All right. So to troll north, we're gonna actually go a little bit faster. So let's go north. And maybe pull us west a little bit. Not by far, because I see that we've got something here. There we go. So now we should see some pretty objects in there. We also have this here.
Another one right there at 12 o'clock, right at the very top of the screen.
Yeah, that's why I'm bringing it down. I'm going to try and bring it down in here. We may miss the one down below, but this looks far more exciting up here. All right.
They have 3 distinct areas there.
Yeah, we do. We got this, we got this, we got that going down. All right, let's check that out. And then we got a nice, beautiful cluster right there.
Cool.
Okay. So we're guiding now, but we're going to let this scope stabilize. We'll do a 30-second shot here. What do you say? Yes, I say so.
Thank you, Izabela.
Good. Oh, thank you. I see she did that again. That's nice. Thank you. Okay, we're guiding, and let's go, and let's get out of night vision mode and go into our stack. That's our previous object. We're going to clear it for now. And now we're north of that. Oh, I should have thought about doing a composite of this whole, a mosaic of this whole area. That's okay. Hey, Asher, thank you. I'm glad that you came along.
Izabela, we're looking at several dark nebulae inside the small Sagittarius star cloud. It is.
Yeah. That's stunning. And we actually have a bright object that came zipping through. Part of me wants to... Looks like a tumbling satellite.
Yes.
If it was a meteor, it'd be a lot brighter, guys, just so you know. Alright, little color correction gives us that. Look at how that looks. Wow. And I'm at 37%, so I have a little more I can go, but it won't be that much. Okay, so now you get this, and you see some of this. Beautiful, huh?
That's cool. Some of the fainter stuff trailing down and to the right, I get that, right? Yeah, that stuff. The very distinct line of stars there, and some of that fainter dark nebulosity has an almost reddish cast to it, or brownish.
Yeah, I'm wondering if the star chains that you see are actually being defined by the black filamentary dust, and thus not really there.
Maybe. But I see one long one going left to right, slightly curved, about a third of the way up from the bottom on the right hand side. And then there's a short bright one going kind of from lower right to upper left above it, and maybe part of that same stream farther over to the right, and another part pointing down to the lower right. And there's another star line just to the upper right of that darkest large clump up near the top.
You mean here?
Yes, that line right there.
So we got this one here. You got that one there. Cosmic Ray says Starlink solar array reflects a lot of light, and he was thinking that maybe that's a Starlink flare. Starlink satellites don't flare, as far as I know. They have all been pretty straightforward. They're relatively small, so I don't expect that they actually flare. Right in the bore. I see a dude in a moon suit tossing a baby in a moon suit. Is this the guy in the moon suit? And this is the baby? It's kind of funny.
Yeah, the baby, you can see the legs hanging down below, and
Right here, right?
yep.
That's a big baby. And this is the astronaut with arms outstretched after throwing him, and he's got a little belly on him.
I think that's his space helmet.
Really?
Yep. And then the fainter
Oh,
dark
it's-
part we were talking about, that's his legs down there.
Oh, these look like legs, don't they?
Yep.
Wow, that's actually pretty cool. Yeah. And, well, maybe it's a baby or it's maybe a small puppy. I can't really tell because there's a tail.
A puppy.
I don't know. Cat? Robin Curtis says there were a bunch of lines of stars at the bottom right hand corner that were very obvious on the night vision image. Yeah, but but once you start to see the total number of stars here, it is just crazy, isn't it? I will say this. When you actually look at regular constellations for the first time under a very dark sky, you could actually get lost. If you're not careful, you could get lost. Orion's the easiest one to see, but good luck trying to see the stars of, say, Cepheus or even Auriga, which has some pretty obvious stars. Under a dark sky where there's stars everywhere, you actually have to work to pick those out. Okay, so we'll do 11 here, and then we'll say go right to an even dozen here. We're gonna round up to a dozen. Here we go. We'll pause this. Save it. And save it exactly as seen. Well, there you go, Daryl. Alright. Alright, then let's go now to our
Yes, thank you.
1 second. Hello.
Hello?
Here we go.
Yeah, that the darkest blob we saw there was Bernard 92.
Yeah, okay.
It was an immense round hole devoid of stars.
Mm-hmm.
Discovered that in 1913.
It's actually called the Black Hole Nebula. You know that?
I do now.
Yeah. It's Barnard 92, and it's also Lynn's Dark Nebula 323. Wow. There's a lot going on here, huh?
Thank you.
Yeah,
That was cool.
it is. I think we should.
Dean, the It's not a dark void, it's a dark cloud or nebula, and it's in front of the star field. It's closer to us than the star field is.
Yeah, Dean, look at my hands on here. Okay, this is a dark cloud, and then behind here are the stars. This is blocking the stars behind, and that's what we're seeing here. We get a lot of that in the universe. There's a lot of dark dust that's obscuring a lot of other things that are beyond them. And this is a case where that's happening as well. I'm going to go to this spot right here. So we're just going to zip on up. It's going to go to one of these other stars up here. We're riding up a little further. I want to check out this area. And we're going to be slewing a star into position. And that's the star. It's one we've seen before. Spheriá.
Borealis.
Yeah.
Messier 22 is right next to it. Not that little one we saw, but it's a little farther over to the left, outside the field.
Yeah. And we can actually see in this case, we can see this black void right here.
Mm-hmm.
That's pretty obvious. So we're going to let that settle out, and then we're going to take some pictures of that.
Mark, I'll be right back.
Okay. Okay, we're guiding now. Hey, Legless Lex, how are you? Asher. That's a funny comment. The shape looks like an astronaut in a suit floating. Wish that was me. Yeah, wait till we discover anti-gravity. Man, I will be wasting so much money on going to an anti-gravity chamber just to float around for a while. I'm telling you. Okay, now that our guiding is going well, let's come in here and do a 30-second shot here as well. Off we go, and then we'll come in and do our stack. Here we are. Okay, this is going to be cool. I don't know what to expect. I haven't been here before. Hopefully you guys are having a good time tonight. I'm enjoying spending time with you guys. Alright, here we go. Oh, look at that. Wow. Okay. If you don't see a charging elephant here, leaving behind the marks that you see in a cartoon, like the zoom, okay, is that not what it looks like? It looks like a charging elephant. This should be called the Charging Elephant Nebula. This is cool. Look how shapely that is. It's like a perfect shape. It almost looks like it can't be true. Wow. But we do see things like that in the galaxy.
Wow, cool.
Yeah, that's the Charging Elephant Nebula. Actually, that's my name for it. Yeah, there's the trunk.
I can see that. Yes, I see that.
There's the head. Okay, and it's making. It even has the zoom lines like you draw with animation.
Mm-hmm. That's those lines like I see with the spider legs.
Yeah. Forbidden Knowledge says, that's so funny. Yes, I'm having a great night. You're doing a great presentation tonight. But the past couple days, I've seen in the clouds lots of elephants. Right. Very cool. Very cool. And of course, Legless Lex shows us an elephant. Very nice. So Tara Marie says this is why she's getting a mermaids in space tattoo. I wonder. Hey there, Skunk Farm. How you doing, man? Brachium. He wants to see Brachium.
What's this?
This is Skunk Ape Farm, off grid. How hard is it to see Brachium?
Yes, I said bassist.
Oh, okay. Yeah, what is it? Was ist Brachium? Or Brachium? Sure, I asked, where's the Mermaid Nebula? I don't know if there's a Mermaid Nebula out there. I don't think there is. Tell me, I can't disclose that information, Asher. Terra Knight, I don't think he means on you. I think he means in the sky. Look at this thing, man. Let me tell you, it's really got good contrast here. Let's zoom in on this again. See, that delineation is so sharp. Wow.
Brachium may refer to the arm or the upper arm, the traditional name of the star Sigma Librae.
Well, that would mean we can't see it.
Brachium of inferior colliculus, part of the brain. Brachium of superior colliculus, also a part of the brain. And brachia conjunctiva, part of the brain. Maybe that's where she's going to get her mermaid in space tattoos on her upper arm. Would she be wearing a fishbowl on her head? You know, a space helmet?
Yeah, right. Yeah, Skunk Ape says he believes it's a red giant.
Yeah.
It is in Libra, and we can't see Libra right now.
Yeah, Libra set earlier tonight, Skunk Ape.
It did. It's still up when we first start, I think, but it quickly sets.
Yeah, barely.
Yeah, because 4647, was that in Libra?
No, 4647 is in the Virgo cluster.
So what were we looking at in Libra then? There was another one we're looking at. Oh, look at this. Beautiful nebula.
Racking my brain, I don't remember. Yeah,
Okay.
and Dean Bostador, per your question earlier, you can see here that this dark nebula, there are stars in front of it, closer than the dark nebula is.
Yeah, the dark nebula is behind. Now it's in 3D too, so you don't know how deep it goes in, but it's definitely a blob. Now, it's really weird to see what look like squared off edges because it makes you feel it's fake, but they're really not squared off. If you saw them up close, you would actually see that it's really not that squared off. It's actually got a lot of convolutions in it. Same thing with the Horsehead Nebula region. You see what look like very sharp delineations, but they're not such sharp delineations when you look at them much closer. It's just so far away that it looks like it has a sharp edge. Just like a cumulus cloud looks like it's very sharply edged. Until you get near it and you see that you can't tell where it begins and where it ends.
Poofy.
Hey, who are you calling Poofy?
That was that astronomical term that
Uh,
Bonnie coined earlier.
oh, okay. Well, then it's okay.
Yeah, but again, per Dean's question, what we can determine looking at this, well, the stars inside the dark area, inside the boundaries of the dark area, are closer than the dark nebula is, and the dark nebula is closer than the stars behind it, uh, outside the dark nebula,
It's
like up toward the top and sides.
it's not a linear separation. It's 3D, remember. So the stars that you see that are bright in front of that nebula, those are probably closer by some distance, but then you can see other stars that are getting fainter and fainter as they get in further, and so it's going to be a three-dimensional. It's going to grade off a variation of stars as
Oh
they go
yeah,
down.
well, sure.
It's in 3D, remember. So I'm not talking to him. I'm talking to everybody else. Legless Lex says, Mark, do you have dreams of being in space? Yeah, while I'm still alive. My very good friend Douglas Trumbull, who passed away this past year, he was the visual effects guy. He did Close Encounters of the Third Kind, 2001: A Space Odyssey. Blade Runner. He did all the visual effects for those movies, and he is going to space. They're actually sending him up on a spacecraft with Nichelle Nichols, Uhura from Star Trek, Jimmy Doohan, who was Scotty, and so Doug will be on that flight, so he'll be immortalized in space. But I want to go while I'm alive. I don't want to go after I'm not alive. It's a wonderful tribute.
You won't need a spaceship to go up there after you're dead.
That doesn't make it any more comforting. Okay, we're gonna stop this here at 18, and I'm not sure what to call this, so I'm gonna just call it what it is. First of all, I'm gonna save it. Okay, I'm gonna save it exactly as seen, and it's gonna save in the small Sagittarius star cloud, which is kind of where it is, sort of a little above it. But
some of the lines of stars I see in this one, if you look at the head of the elephant, it looks like when they dress up an elephant in India, and it's got
right here.
Yeah, all those lines, the bigger curved lines, the little ones. There's 3 or 4 of them there.
Yeah, this stuff comes down around,
Yep.
and they got this stuff. It's like wow.
When they dress up an festival for
a
festival or something.
Yeah, it's a festival elephant. There's a festival elephant. Okay, so now we'll be done with this one. That was really pretty. Alright, and okay, go to night vision mode on this one. You can actually see that amazing dark spot because it's so bright. Look at that. All right.
Well done.
Yeah, that was a pretty one. Now let's see. Let's bring up our planetarium here. And let's go see. So that's where I was. I'm going to try right here. That looks interesting. This is going to be northeast of the Eagle Nebula. Actually, I think I can just steer us that. Oh, I'll let it take us there.
Legless Lex expanded on his question to you.
So what I meant was, since you're an astronomer and always gazing at the heavens, does that affect your dreams when you fall asleep? Also, Virgin Galactic is off the edge of space for 450K for 90 minutes. I would go up on Blue Shepard or Virgin, in a heartbeat, without even thinking about it. Without a doubt.
Not for 450K, I wouldn't.
Well, too bad. You don't get to go then.
If it was free, I would, if I won it.
Oh, if it's free.
A Blue Origin, that's just an expensive amusement park ride is all that is.
Yeah.
And I swear, Jeff Bezos, when William Shatner got to ride the Blue Origin,
yeah,
and they touched down, Shatner was trying to say something profound, and Bezos interrupted him.
Yeah.
Got right in the middle of it.
Yeah, I thought that was poor. I thought that was very poor. But...
yeah.
Okay, we're going to try 30 seconds at this little special spot. I don't know what's here, so let's find out. Okay, we're going to clear the Charging Elephant Nebula. Alright, let's see if we got some variations here. What do we got here? This is 50%. Let's jump out to 100. I'm sorry. Let's go auto frame. Oh, that's interesting. Sort of an edge. A little diffuse nebula here. Let's see. Oh, we went up there before. That's actually a pretty bright nebula. No, we haven't been here. This bright and dark nebula in this one frame. So let's stop this. Okay. And go into night vision mode here again. 1 second shot. There we go. And now let's come back to this. And from here, let's say it's actually right nearby, so I'll just steer to it. Yeah, we're gonna go at just a little bit faster than normal speed. And we're gonna take the telescope north and then east. Okay, and now east to the center of this field. Oh yeah, see, we got some fun stuff in here. Okay, so this will be about right. Look at that. So there's something cool here. Let's go find out what it is. See, in a lot of ways, we're exploring in the way that the earlier viewers of the universe would explore.
Second star to the right. Keep on till morning.
That's right. That was Peter Pan.
Well, it was also Captain Kirk.
Yeah.
I'm sure Peter Pan's where they got it from.
Yeah, I think so.
They like to borrow from classic books.
Yeah.
Shakespeare and stuff. Moby Dick.
Well, as it turns out, the reason that they did that was because of William Shatner's classical theater experience doing Shakespeare.
Oh yeah.
I remember when I saw Shatner once at a theater. I got to meet him, but not for reasons that were because I was so special or anything like that. No. It's because on his way out, when he was trying to leave the building, he burst through the back door to get out to his car to go back to New York. And he ran into my father, who he knocked right flat on his butt. Wow. Oh, wow. And when he knocked my father down, he looked down and he had this look of horror on his face. He was like, "Oh, I am so sorry. Let me help you." And he picks him back up. And my father says, "Oh, I'm okay, Mr. Shatner. Please, call me Bill." And they just had a conversation. And Shatner got back in his car. My father leaned on the window, and they started talking like buddies. Okay? And I'm sitting there and going, my dad's talking to Captain Kirk. My dad's talking to Captain Kirk. My dad was knocked on his butt by Captain Kirk. It was actually quite funny.
I remember when I was in Germany back in 1990, we were attending a trade school over there. And we were there for 3 weeks, and well, we couldn't go out partying every night because I mean it gets to you after a while.
Yeah.
So sometimes I just spend the night in my hotel room watching German television, which is mostly really boring talking head shows.
Yeah.
But they'd have variety shows on sometimes, which were very kind of corny, and they love old Western movies over there. And they would play a B Western every night.
Huh.
And one night they played the William Shatner Western.
Oh, I remember
I think
that.
it was called White Apache. Have you ever seen that? That was the first time I ever saw that movie. He was
remember
like
him doing that.
He was. I think they were twin brothers. He played both roles. He played the one guy lived with the wife. He was a cowboy or a sheriff or something, and his brother grew up with the Apaches and was on the warpath. And the Apache Shatner wore war paint. And if you remember back in the 60s what surf stripes looked like. It's like they'd paint on surfboards and on cars and stuff, like Corvettes.
Yes.
It was a broad stripe and a little skinny stripe next to it. And his face was painted in surf stripes. And that had to be the cheesiest movie I ever saw. And it was double funny watching it. It was translated into, it was dubbed in German.
So that made it even funnier.
Yeah.
Okay, so let's see here. Yeah, I don't want to look at this actually. I want to keep moving.
I'm gonna have to call it a night soon.
Okay, let me get rid of my azimuth lines here. Here we go.
There's Sagitta.
Yeah.
There's the dumbbell.
Yeah, we're not going there. Not going here. We're going.
Camus Igni.
Yeah, we're gonna go here. It's upside down right now, but that's okay. Alright, we're gonna go right about here and then we'll place it from there. So I'll just tell the telescope to go to this location. There we go. It's probably going to go to Deneb, which is the brightest star in Cygnus. You look at the telescope, it's going way up over the top here. Yeah. That looks like Deneb. Yep. Deneb is the tail, the back end, the hindquarters of the swan. We come over here. This is Deneb over here. And if you notice, if you bring up the art, okay, that's the hindquarters of the swan. And from Deneb...
I'm sorry, speaking of tails, forbidden knowledge fell on his.
What are you talking about? Oh. Oh. Sorry to hear that. We have smashed our coccyx bone a number of times. That's beautiful.
Did you know that, what's her name? Marina Sirtis from Star Trek Next Generation, Commander Troy, you know. She broke her tailbone on the show once.
Ow.
She had to fall back like she had been stunned or something, and she landed right on her tailbone and broke her coccyx.
Ouch. Okay, this is the Cygnus Wall as part of the North America Nebula. And normally we do the Pelican as well, but I'm going to just do this for now. I want to do just this part right here. And we'll see other pieces out here, but this is just, there's so much stunning detail in here. The telescope is pointed almost straight up, so this is going to be the best, absolutely best view of this for tonight. And we'll do a exposure, and this one I'm actually going to raise this to 350 gain, okay, and do a 40-second exposure here to pull out all the detail we can get. So there we go. And we'll bring up our live stack. Yeah, and this is gonna clear, and we're gonna clear it here. This is exciting. Wow, look at that. How pretty. Watch this now when I process. Boom. Ah. What a beautiful area of the sky. This is directly straight up the North American Nebula. This is Florida. This is the Gulf of Mexico in this so-called look. And this is what's called the Cygnus Wall. And it's a beautiful wall of nebula, emission nebula, that goes all the way up through here. And it's ionizing hydrogen as well. The stars are the stars that are ionizing this gas are actually I think it's Deneb that's actually ionizing these. But these stars, this area is also full of dust. There's a lot of dust here, but it's mixed with mostly hydrogen here, so you see the dust as well as the hydrogen gas. Then over here you see just the dust, which is superimposed in front of, once again, the background nebula here. That's why you see it like this. Look at that. Isn't this amazing? I find this to be one of the prettiest regions of the sky. Look at the detail in here. Zoom out a bit so you can see it. This will be the last object tonight, guys. Wow. Absolutely stunning. Asher says, totally mind-boggling. Isn't it, though? It's beautiful. JSCO77, hi there. I didn't think I said hi to you earlier. Glad to see you. And he says, wow, wow, wow. Yep. Let's zoom in on this guy here. Look at the complexity in these clouds. Just beautiful. Look at that. How absolutely beautiful.
Dark nebulous. As usual, the dark nebulosity is really fascinating.
It is. You notice an area like this is actually doubly fascinating because you see this dark nebula, then you see like this hazy stuff behind it. That's a mixture of hydrogen gas with dust, and some of it is being softly ionized, which is why it's sort of glowing red. Okay? And you still have this dark dust, which is preventing the light from getting to us from this soft glow behind it. Just incredible. Every little area of it, every nuance is just a beautiful picture.
Folks, if you remember when we were looking in Sagittarius, like at the small Sagittarius star cloud, Messier 24, we were looking at the next spiral arm in from us at the Sagittarius Carina spiral arm. And when we look up toward Deneb here in Cygnus in the North American Nebula, we're looking 90 degrees away from the center of the galaxy, and we're looking out toward the next spiral arm out.
This is amazing. And YouTube for Green Future said clouds are bigger than the Earth. Actually, these dust clouds are bigger than our entire solar system and far beyond. These clouds are not measured in millions of miles or thousands of miles. They're measured in light years in length. So we could probably put a number of solar systems in here. Okay, probably 10, 20, end to end. You know, possibly. That's how big these features are. That's why we don't see them change very much at all. You know? Robin Curtis asked the question, why does this nebula appear white? Actually, we're looking at ionized hydrogen in here, right? And so this color here, this is just a color sampling done by the camera. But when we color correct, this nebula will appear redder, I should say. In fact, let me color correct now and see what it will do. Okay, it color corrects the stars, but This is just a beautiful. It's just messy, isn't it? It's just a messy spot in space. But it could be due to the density of the cloud, or what is it? Whatever we have there. This right here, this red, is what the rest of this really looks like. And I'll have to do color correction, offline to actually make it look like it's supposed to look. It's really pretty though.
I think I'm going to have to eat my hat on what I just said.
About what?
Its distance. I don't think it's the next spiral arm out. North American Nebula is about 2,590 light years away.
Yeah. We have the Perseus arm after that.
Yeah.
Which is farther away. YouTube for Green Future says, why do they appear influenced by wind when wind does not exist in space? It's true. Wind, not as we know it. But what is influencing this are called stellar winds. And give you an example. Okay, let's zoom right in on this. Okay, because we can. All right, we're zoomed in to, at this point, we're at 160? Yeah, 160% of our zoom. So we're over 100%. But see these streaks here? These radial streaks. These are all created by vast galactic motions and by stellar winds that the stars start stuff moving, and there's nothing to stop it except other stuff like it, and eventually it could stop, but the stellar winds push material along and create all these variations in the filaments that you see. All this stuff is created by the vast combinatory actions of vast amounts of stellar winds acting on all these. This right here is a gorgeous picture alone. Just this is beautiful. Wow. So the winds we're talking about are stellar winds. And what are stellar winds? Stellar winds are at a star's core is generating a lot of energy. That energy radiates away from the star, and what comes with it is a stellar wind. Particles from the surface of the star that are basically plasma, meaning just protons and electrons, for mostly hydrogen atoms, and they go racing away from the star at high speed, and they're charged, okay, with an electrical charge. And so they shape a lot of the universe that we see in front of us. And every star you see in this image, every star, okay, whether it's near us or far away from us, they all have stellar winds. One thing you'll notice is that inside the nebula, notice how the stars seem dimmer. These stars here are probably inside the nebula, and their light is extinguished a little bit by the nebula itself. That's called interstellar extinction, and also interstellar reddening, because you'll notice that many of these stars look a little yellowish or reddish, and that's because we're looking at their light through this dust, and this dust is what causes the light to look red. Think on Earth how a volcanic eruption throws lots of dust in the air and creates some of the most beautiful sunsets we've ever seen. Beautiful red, scarlet red sunsets. That's because the blue light is being scattered by the dust in the air, and only the red light's getting to us. Same thing here. It's a universal phenomenon, scattering. And in fact, it's called Rayleigh scattering, if you want to know the name. And Rayleigh scattering scatters the blue light, the dust and the atmospheric molecules in our case, scatter the blue light. Dust clouds like this scatter the blue light as well. And so the starlight that does reach us has had that blue light stripped away in part. And so the stars look redder than they should. The stars like this, they may not be red stars. They might be white stars that are between us and this cloud, or possibly in this cloud, and thus they'll appear a lot more red. Wow. I'm stunned. This is a beautiful picture alone. Just like that. Look at that. We got an emission nebula and we have a dark nebula right next to each other.
I think we've
That's
covered this before. Edwin Hubble thought that Deneb might have been responsible for lighting up the North American Nebula, but it's not hot enough. Nebula spectrum shows it being heated by a star hotter than 30,000 K. I'll jump some here.
Oh, that's right. The star is actually in the dark nebula. We can't see it.
Yeah, in it or behind it.
Yeah.
The central dark cloud is L935. I assume is Lin 935. Well, let's see. There's a star J2055551.3 plus a bunch more numbers lying right in the center of Sharpless 2-117. Temperature over 40 K. It's almost certainly the ionizing star for both North America and Pelican Nebula. And they call it the Bahamas star. It's just off the coast of Florida, as seen in the nebula. But I gather it's behind the cloud.
Yeah.
It said it's faintly visible, but it's very much extinguished by the dark cloud.
Yeah. And the dark cloud isn't very dense. Like I said, it's like only about anywhere between, very few and up to 10,000 atoms per cubic centimeter. And that may sound like a lot, but when you think that 10,000 atoms in a cubic centimeter, all right, well, we normally have 10 to the 19 atoms in a cubic centimeter of air, roughly, if I recall. But that's actually shows you the difference in density. And air is like, it doesn't even stop you. Oh man, this is so stunning. Wow. Alright, we're at 21 stacked here. I just want to keep going through it. I want to go looking up here. Look at this. Let's go up here. This is part of what's known as the edge of the Pelican. The Pelican is just to the right of this. But I didn't want to look at the Pelican tonight. I wanted to look just at this location. Wow.
YouTube for Green Future. We cannot see stars outside our own Milky Way by eye. If you mean like in other galaxies, we can certainly image them though.
And we have. With our telescope,
Yes.
we've imaged the stars in the Andromeda Galaxy.
Yes.
Which I think is probably on its way up.
I bet it's well up by now.
Yeah. There it is.
Just one more.
Yeah. Hello. Let's see if we can do it. Because then I can show people the exact things we're talking about.
It's maybe halfway up in the northeastern sky.
Yeah,
Think
right
it's
here.
cleared the roof yet?
I'm going to tell you in a second. Oh, yes. Wow. You want to see the Andromeda Galaxy, guys?
Sure. Just one more.
Yeah, that's me.
Izabela
Just
said.
one more. Okay, I put in... Wait, I already spelled this out. How come it did that again? I had put in... oh, no, I didn't. North America Nebula. This is going to be beautiful.
We'll start
Heck yeah.
clouds or something else.
Yeah, they're beautiful. Okay, now just to show you, the image is going to be saved to the database that you'll be able to get to in just a few seconds. Is this one? Look at that. That's actually a nice composition.
Yes.
It really is. Okay, so that's good. I like that. I'm glad I did that. All right, so we're going to pause this now at 25 frames. Oh, wait. We'll go to 26. Okay, we had 26 frames. Now we'll save this like this, and then we'll save it exactly as seen. Okay. And then we'll get rid of the stack, and we'll clear the stack when we come in again. There it is. A beautiful, beautiful image. Okay. Now we'll go into our next image search mode, and we're going to go and enter our night vision mode here. And I have to go check out. I did select this already. Waiting. I want to get rid of that too. There we go. Okay. And before I do that, I'm going to bring back my telescope view here. There we go. Okay. And now let's go to the famous, the absolutely outrageous, most amazing Andromeda Galaxy. Off we go. And we're off. We also have Messier 33 as well.
Nope. You can, but I'm going to go to bed after this.
Oh, no, I'm not going to do that. I'm just going to do Andromeda. I'm not going to do the other.
Yeah, right.
We have to wait until... No, I am. We have to wait until the it gets higher in the sky. Okay. And which star are we going to with here? Oh, okay. We're in Andromeda. Is that Alpharats we went to? Well, it doesn't matter because we're going to Andromeda Galaxy right now. Whoa. Yep, perfectly placed. And I'm just going to actually raise it up a little bit. I'm going to go south a little bit. Okay, we'll try that. So I want to show you this. See this blue area right here? This is an area of hot blue young stars, and you got to see these to believe them. Okay, so we're going to get our guide going. We got our guide star going. All right, and now we're going to do a... we only need 25 seconds. We're going to do 25-second exposure here. All right, off it goes. There's our yellow progress bar over there. See down the bottom? Okay, and we can do our live stack here. And obviously we're going to clear this last one that was here. And here we go, the Andromeda Galaxy for the first time this season, guys. And oh yeah, a little bright because I had this on high mode here. We're going to get that out of there. Okay, now let's actually process this a little better. Oh, look at that. Let's check the stars, make sure that the guiding was turned on right. Okay. Wow. Now, Andromeda, like our galaxy, has companion galaxies.
Yep.
Okay, here's one here.
It's M32.
Yep. And then we have 110 right here, Messier 110. These are elliptical galaxies, galaxies that basically have very little gas in them. Although, Messier 110 does have some gas in it, which you can see as these little clumps of gas. Okay, and dust, I mean. So that's pretty interesting. But most ellipticals don't have any gas in them and dust. They seem to be devoid of that. They're just stars. Boy, I'd hate to live in an elliptical galaxy. Look how boring they are. They're very boring. But yes, this is the Andromeda Galaxy. Let's pull out and color correct this.
You know, when I was looking up Messier 24 there, small Sagittarius star cloud, it said that it was very similar to a certain, I believe it had an NGC object designation in the Andromeda Galaxy. If I had to guess, it's probably that bright spot there at the lower right. Yes.
Okay.
I don't know if Stellarium would show that by NGC number.
I don't know. I'm tending to doubt it. What's interesting is, though, for Messier 33, they show all those things, and,
yes.
And I don't know why they don't do it with this.
Yeah.
Wow.
Oh, you can see that bright spot.
Yeah, it's. Yeah, that's right here.
Oh well. Yeah. Oh well.
Now look at that. That's just beautiful. And if you notice, the Andromeda Galaxy has nebulae just like ours. Here is a H2 region. All right. And that H2 region is sitting there proudly creating stars. It's not the only one. There's many such regions in this galaxy that are doing that. And you can see them if you look closely. Yes, you can. Messier 31 also has this dark dust in here, like our galaxy does, and like other galaxies do. Normally I stop when this music comes on, but we're gonna keep going a little bit longer. All right, because I want to be able to just allow a few more exposures to be taken. Here's another beautiful hydrogen emission nebula region. There's another one here. It is just full of amazing detail. Now that's overexposed, right? But we have beautiful dynamic range, so what I could do is I can pull out a little more detail down there. Okay, so that's as far down as we can go. That's pretty good. Wow. Wow, this is really pretty. Now, one thing to keep in mind, and Daryl and I have talked about this before, is that all these stars you see here are in our foreground galaxy. And you can't see individual stars in the background galaxy here except in pretty special circumstances. Like in here, down in this section here, there's so many stars here that you can see these individual stars in the OB association in this distant galaxy over 2 million light years away. You're seeing them as they were 2 million years ago, but you can still see them. Somebody wants to see something?
Izabela was wondering about M33 and Triangulum.
Oh, okay. Thank you, John Leonard Walson. Oh, this is just beautiful. Oh yeah. Okay, we got 17 stacked here. See the subtle beauty in this galaxy. You can see the subtle colors. Look at this right here. Look at this. Look at this beautiful hydrogen emission nebula region here. Look at that. That's stunning. Beautiful knots in this galaxy. Knots and structures. Let's see if we can actually let's see if we can make those even brighter or sharper. So we're going to go up to a sharpening level of 2. And that shows us a little more detail in there. How about that? That's really pretty. Look at that, Daryl. That's really gorgeous.
It is.
Wow. And we also have a really interesting feature here. This is a well-known association of hot young stars. And then in the far spiral arm we have more. Really pretty. And when I look at this, I see star formation, I see planets and potential habitable planets in a galaxy that is literally massive. It's so much more massive than ours. We have about, say, 100 billion stars. This galaxy is so much larger that it has almost 1 trillion stars. 1 trillion. And by the way, this galaxy is so big in our sky for a very important reason. It's because it's coming right for us. And in about 3 or 4 billion years, we are going to pass into each other. Notice I don't say collide. I've said that before. There is no collision. We're just going to pass through each other, and it's going to reform the galaxy into a new shape, something beyond what we are now. We're a spiral galaxy now, a barred spiral galaxy. We have a bar through our nucleus of stars, off of which the spiral arms are. It's actually going to be a very, very interesting time in the evolution of this planet and our solar system. Now, by the time the Andromeda Galaxy passes into the Milky Way Galaxy, our sun will be reaching near the end of its life. So we have about 5 billion years to go. We'll see what happens. You know, I have a feeling we're going to see, by that point, we will have colonized nearby stars, because we know we have to leave Earth. We have to go to stars that are young enough to support us and that will be around for a while. The alternative is to learn how to live in deep space. And to do that, I'm not sure how we would do that. I mean, we can make an arc kind of thing, you know. Okay, 25 stacked. And we'll pause it here and save it. Let me,
I went back and did some looking. I believe that bright star cloud to the lower right of the nucleus is NGC 206. That is the one they compared M24 to.
Okay. Okay, live stacking is done. And we will save this now. This will be up there in seconds for you to take down. Let's see if we can do a little more processing on this. Make it look a little better. Maybe like this. Yeah. Good night, Judy McClellan. Thank you for coming. It's so nice to see you. Wow, this is really pretty. Okay, and we'll save this just exactly as seen now. Hoo-wee-dee-dee. Who knows the cartoon that's from?
Say that again.
Hoo-wee-dee-dee. Give me another hint. What happened? What happened, Muskie? What happened? Hey, Vince. That was Vincent Van Gogh. Muskie Muskrat. And who's DD? Yeah, David Schmidt got it.
Deputy Dog.
Hi, Sheriff. Deputy Dog, get your butt back here. Yes, Sheriff.
God, I hated that cartoon.
Well, thank you. I'll never mention it again. Okay, folks. Well, I hope you guys have a good time.
Was that a Hanna-Barbera cartoon?
I don't remember.
I mean, that was when cartooning about hit rock bottom, I think.
All right. Okay, well, guys, thank you so much for coming tonight.
Who was the penguin and the walrus?
Chili Willy.
Was the walrus.
Chili Willy was the penguin.
Okay, no, that was somebody else then.
It was Woody
He
Woodpecker.
talked like Maxwell Smart.
Yes.
I think the same actor voiced him, in fact. We'll save that.
Wally Cox did a lot of those. That was Underdog. He did. So Wally Cox. There's no need to fear. Underdog is here. When Polly's in trouble, I am not slow. It's hip 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 and away I go. The secret compartment of my ring I fill with the Underdog Super High Energy Pill. It was the first cartoon that actually promoted drug use. Hidden drug use. The secret compartment of my ring I fill with the Underdog Super High Energy Pill. Back then, nobody really thought about it. Oh, this is beautiful, guys. This is just beautiful. All right, well, thank you, guys. And it's time for us to go bye-bye for tonight. And we'll be back on the next clear night. Maybe we'll get some moon views in over the next couple days, too. But, Daryl, thanks for coming along.
Oh, sure. Thanks for having me.
Yeah, and we will see you all on the next one. I'm going to just clear this and get rid of the stack. This is up. Izabela, I believe, said that the Andromeda Galaxy is on its way up there. And so it'll be there in a minute. So you guys enjoy it. Thanks for coming. And we will talk to you soon enough. I appreciate all of you. And I hope you have a good night. So we'll see
Good
you
night,
later.
everybody.
Good night.